Hello, and welcome to Intech Centre's Functional Skills tutorial. My name is Kerry-Ann, and I'll be guiding you through the Functional Skills Mathematics sample paper for Level 2, provided by City & Guilds. Please note that this video is made for educational purposes only for Intech Centre's customers and learners, and in no way is it affiliated with City & Guilds. Please also note that there are different ways which you can answer the steps and questions in the exam, and that this is only a guide. As a reminder, Intech Centre is one of the leading training facilities based in Islington, London, and we offer government-funded courses in English, Maths, IT and Employability, as well as private courses and the opportunity to just sit your exam. If you are interested in any of the courses available at Intech Centre, you can inquire here, and one of our advisors will get back to you within a few working days. Alternatively, you can give us a ring on 020 7354 5655. So this video is the third video of 3 parts, and I'm looking at the City & Guilds sample paper 3 for Level 2 Functional Skills. So the scenario 3 on this paper is based on half marathon training. There are 25 marks available for this task, and it is important that we check our work as we go along. This task is about training to run a half marathon event. A half marathon is 13 miles. To complete this task, we will need to work out the probability of winning a free gift, work out trends for improvement, calculate target times, work out averages and range, and compare averages. And it is important that we check our answers. So we will start. Question 1 is worth 4 marks, and it tells us that we attend a gym to work on your fitness and improve your running times. Each month, the gym gives away 1 free gift to the first 8 members who attend 10 sessions. The free gift is chosen at random by a computer. This month, you are the first member to attend 10 sessions. What is the chance that your free gift will be a sports bottle? We must work out this probability. So, the first 8 members who attend 10 sessions get a prize, and there are 8 prizes. We are the first member to attend 10 sessions, so all of the prizes are up for grabs. And we want to know what the chance is of getting a sports bottle. So we have 8 prizes in total. So our denominator will be 8. And there are 1, 2, 3 sports bottles available. Therefore, our probability will be 3 over 8. And to get this in a decimal form, we can use the calculator to assist us. So we will do 3 divided by 8, which gives us 0.375, so that will be our probability. And we can put that into the answer box given. We must now plot this probability on the probability scale. So probability scales are always between 0 and 1, which leaves the middle one as 0.5. As this is 0, this will be 0.1, 0.2, 0.3, 0.4. Our probability is 0.375, so it will go somewhere around here on the scale, and we can use the x given to plot this. So I've plotted my x there, which makes sense as this is 0.1, 0.2, 0.3, 0.4 and with 0.375, so it'll be somewhere along here. So question 2a is worth 4 marks, and it tells us that we will train with a running partner JJ, and we both record our last 9 practice sessions for running 12 miles. The graph shows the times for the last 9 practice sessions for me and JJ. So we must draw 2 straight trend lines on the graph, one for you and one for JJ, and then we must explain what the trend lines tell us about our running performance compared with JJ's. So, to plot a trend line, we make sure we hit the first and the last target and get as closest to the other ones as possible. So for you, I'll plot the trend line here. And for JJ, it will go along here. So now we've plotted our trend lines, we must make 2 comments about our running performance. So as we can see from the trend lines, you start off slower than JJ, however, as the sessions go on, we end up running quicker than him. And we improve at a quicker rate than JJ as there is a deeper gradient with the correlation. So two possible comments on this is that both runners are getting faster as the sessions go on, which we can see as there is a decline in both lines on the graph. Another possible comment will be that I am improving quicker than JJ, which we can see because there is a deeper gradient on the trend line for you. So we can just put that comment into the comment box. And there will be two good answers in the exam that will get you the marks. So question 2b is worth 4 marks, and it tells us that you and JJ have a target time of under 2.5 hours for the half marathon. This formula predicts how long it will take to run a half marathon. The half marathon will take place in 3 weeks' time, and we must use the graph in question 2a to find the improvement factor and the latest practice times. We must use the formula to work out the predicted times for both you and JJ, and work out whether you and JJ will achieve the target time and explain our answers with supporting calculations. So we've got the formula that P equals 1.36T minus FW. So we must put our data into this, and I will start with U. So P equals 1.36 multiplied by T, which is the time for the latest practice session in hours. So if we scroll up to the graph, the latest practice session was practice 9, and we are the blue dot, so our latest practice time will be 1.9 hours. So we will put that in. We then must minus F times W from this. So F is the improvement factor in wheat, is the improvement factor, which for you is 0.12. So we will have 0.12 times W, which is the number of weeks before the half marathon, which we know is in 3 weeks' time. So this will be times 3. It is important when doing these calculations to make sure you do the multiplication first and then do the addition or subtraction. So we will have 1.36 multiplied by 1.9, which gives us 2.584. And then we will have 0.12 multiplied by 3, which gives us 0.36. So we will have 2.584 minus 0.36, which gives us 2.224. So that is the predicted time for you in the half marathon in hours, 2.224 hours. So next we will do JJ's. So we've got P equals 1.36 multiplied by JJ's time, which is here, which falls on 2.1. So JJ's latest practice time was 2.1 hours. We will then do the improvement factor for JJ, which is 0.06, multiplied by the number of weeks before the half marathon, which is 3. Again, it is important to do the multiplication before we do the addition or subtraction. So we will do 1.36 multiplied by 2.1, which is 2.856. And then we will do 0.06 multiplied by 3, which gives us 0.18. And if we deduct this from 2.856, we get 2.676, which is JJ's predicted time to complete the half marathon. So we know that our target time is 2.5 hours, which is 2.5. We know that our predicted time will be 2.24, which is less than 2.5, so we will achieve the target time. And the reason is because 2.224 is less than 2.5. So JJ's target time is 2.676, which is higher than 2.5, so he will not achieve the target time. And the reason is because 2.676 is greater than 2.5. So we've answered all parts of the question. We've used the formula to work out the predicted times. We've then answered whether you and JJ will achieve the target time, and we've explained this using supporting calculations. So we should get good marks for this question in the exam. And it is important that we make a note of the predicted time, as we will need it for question 3C as stated. So question 3A is worth 4 marks, and it tells us that these are the results for last year's half marathon for the teams in your age group, in hours, minutes and seconds. And we must work out the median of these 16 runners. Now, to find the median, we have to put all of the data in order from smallest to largest. So, the smallest will be 1 hour, 50 minutes and 48 seconds. We then have 1 hour, 53 minutes and 24 seconds. We then have 1 hour, 55 minutes and 48 seconds. We then have 2 hours, 3 minutes and 0 seconds. We then have 2 hours, 4 minutes and 12 seconds. We then have 2 hours, 5 minutes and 24 seconds. We then have 2 hours, 11 minutes and 24 seconds. Then 2 hours, 12 minutes, 0 seconds. 2 hours, 12 minutes, 12 seconds. 2 hours, 14 minutes, 24 seconds. 2 hours, 18 minutes, 36 seconds. 2 hours, 34 minutes and 48 seconds. 2 hours, 36 minutes and 0 seconds. 2 hours, 52 minutes and 12 seconds. 3 hours, 13 minutes and 12 seconds. And finally, 3 hours, 52 minutes and 48 seconds. So we have 16 values in total. So as this is an even number, we'll be looking for 2 sets of data in the middle. So we'll be looking for the 8th and the 9th value. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So our 8th value is 2 hours, 12 minutes and 0 seconds. And the 9th value will be 2 hours, 12 minutes and 12 seconds. So in order to find the median with 2 numbers, we have to add them together and then divide by 2. So we will add these together. So we'll have 0 seconds plus 12 seconds, which will be 12. 12 plus 12, which is 24, and 2 plus 2, which is 4. So we'll have 0, 4, 24, 12. We then must divide this by 2. So 4 divided by 2 is 2. So we'll have 2 hours. 24 divided by 2 is 12. So we'll have 12 seconds. And 12 divided by 2 is 6. So our median time will be 2 hours, 12 minutes and 6 seconds. And we can just pop that into the answer box below. So question 3b tells us that the mean time for these runners is 2 hours, 23 minutes and 8 seconds. We must compare our mean with our median that we've just worked out here, comment on any differences and explain why the median is a better average for this data. So we've got 2 hours, 23 minutes and 8 seconds for our mean and 2 hours, 12 minutes and 6 seconds for our median. So one comment will be that the mean time is slower than the median time. And an explanation for why the median is better, we can see when we look at all of the results. So as seen here, there are two extreme values in this data of 3 hours and 13 minutes 12 seconds and 3 hours and 52 minutes 48 seconds. These are a lot larger than any of the other data, so the median would be better because the median takes the middle values, so it excludes any outliers or extreme values, whereas the mean would take these into account, which is why the mean time is higher than the median time. So our explanation will be that the median is better as it ignores any extreme values. And that is two good answers to get the 2 marks given in this question. So question 3c is worth 2 marks again, and it says that we must compare your predicted time from question 2b with the results from last year's half marathon and make one comment about it. So for this, we've got the results from last year's half marathon. We will take the median for, which will be 2 hours, 12 minutes and 6 seconds. And our predicted time was 2.224 hours. So in order to compare these accurately, we must change them so they're in the same format. So I will change our time to be in the same format as the median. In order to do this, we will do 2.224 multiplied by 60, as there are 60 minutes in an hour, which gives us 133.44. So that tells us that there is 133 minutes and 0.44 seconds. So to find out the seconds accurately, we will do 0.44 times 60, as there are 60 seconds in a minute. Which gives us 26.4 seconds. And from that we can just round down and take the 26. So we've got 133 minutes and 26 seconds. So we need to get this in hours. So we will do 133 divided by 60, as there are 60 minutes in an hour, to see how many hours will be in this minutes. So it gives us 2.216, so we know that that will be 2 hours. We will then do 2 times 60, which is 120, so 133 minus 120 leaves us with 13 minutes. So we can pop that in, and then also the 26 seconds that we got earlier. So now we've got them in the same format. We have 2 hours, 12 minutes and 6 seconds for the median, and our predicted time is 2 hours, 13 minutes and 26 seconds. So these times are very similar, so our comment will be that my time is similar to the median, and that we are just a little bit slower. And that would be a valid answer to get you marked in this question. So now we will move on to question 4. So question 4A is worth 3 marks and it asks us to work out the range for all the runners and explain what the range shows. So to find the range accurately, we will do the fastest time from the slowest time. So our slowest time will be 3 hours, 52 minutes and 48 seconds. And the quickest time will be 1 hour, 50 minutes and 48 seconds. So we must deduct these from each other. So 48 minus 48 is 0, so there'll be 0 seconds. 52 minus 50 is 2, so there'll be 2 minutes. And 3 minus 1 is 2. So therefore, the range will be 2, 2, 0. So 2 hours and 2 minutes and no seconds would be the accurate range. Now with range, if the number is high, then this shows that the data is inconsistent, and if it's low, it shows that it is consistent. So we have 2 hours and 2 minutes, which is a big difference in the times between the fastest and the slowest runner. Therefore, this shows that the data is inconsistent and that there's a big variation of times on how quick people complete the marathon. So our explanation will be that the range shows a big difference between runners. Therefore, this means that the data is inconsistent and varies a lot, which would be a good comment to get your marks in the exam. So question 4B is worth 2 marks and it tells us that we must check one of our calculations used in 4A and use a different method to the one used originally. So in 4A we did 3 hours 52 minutes 48 seconds minus 1 hour 50 minutes and 48 seconds, which gave us 2 hours and 2 minutes. So to check this, we will do 2 hours and 2 minutes plus 1 hour and 50 minutes and 48 seconds in the hopes to get 3 hours 52 minutes and 48 seconds. So we will have 0, 2, 0, 2 plus the 1 hour 50 minutes and 48 seconds. So if we add these together, 2 plus 1 is 3. So we've got 3 hours. 2 plus 50 is 52. So we've got 52 minutes. And 0 plus 48 will give us 48 seconds. So this is the same number as we started with originally for the slowest running time. Therefore, we've successfully checked our calculation and proved that we did the right method. So this is the end of the assessment now. I hope you enjoyed the videos and thanks for watching. If you have any queries about Intech Centre, then please visit our website or give us a ring to let us know what you are interested in. Thank you.